Welcome back, Torino, to English part of Biennale Technology. I'm Castro, and welcome. This is One Quadre podcast. We have a special guest. Who turned out to be an Iranian. She is working on a PhD project focusing on decreasing energy consumption in both distributed computing and communication for cloud-based cyber physical systems. Am I right? Could you please introduce yourself?
Thank you for the introduction. My name is Sepide Saidi, and I think they gave you the wrong note because I'm working on approximate computing for power and energy savings.
Okay.
But don't worry,
I'm
going to explain about that.
I'll change it a little bit. Don't worry.
Okay, so...
So shall I call you Sepide? Is it okay?
Yeah, of course.
All right, Sepide. Welcome to your podcast.
Thank you.
Let's just start with a question. What is the general subject of this micro research you're working on? Could you explain a little bit more to us?
Okay, we're working in this project called Approximate Computing for Power and Energy Optimization, acronymed APROPO. And it is, as the name shows, we're trying, along with my colleagues in 14 other colleagues in 14 other European universities. We're trying to find approaches to use approximate computing in order to save energy consumption and things like that. But what I am focusing here in Polito in general is that we are trying to find a way to estimate and in some cases predict the impact of approximate computing techniques applied to a complex computation.
Okay, so this is an international project, am I right? Because you said before, there's 40 international universities are working on, or they're involved.
Yes, of course. It's the project is funded by Horizon 2020 Marie Curie actions. So yes, there are 14 other ESRs or early stage researchers, and we are going to be better researchers and contribute to this field of approximate computing.
Sure. Well, so this is going to be, as I don't understand, if you could explain a little bit, this is going to be reduce the consumption of the energy, or is it just going to predict our...
The thing is, we use approximate computing, which is any technique that helps you reduce the accuracy of the computations. For example, making it inexact. Every computation has a result.
Of course.
And that result, in some cases, in some applications, can be inexact, not as accurate as possible. So we are using that opportunity in some applications, for example, neural networks that are tolerate to some loss of accuracy to generate that inexact output, but gain some on some performance metrics, like reduce the power consumption, reduce the execution time of the application, and at the end, reduce the energy consumed.
Is there any applications that you could give me an instance or any example of it right now?
In general, approximate computing techniques are applied to applications that are very tolerant to some level of accuracy loss. For example, neural networks are very popular application these days, but artificial neural networks, especially CNNs, convolutional neural networks, and deep neural networks, spiking neural networks, which we've been working on. For example, in artificial neural networks, let's say, you can reduce, as some people know who are working on the subject artificial neural networks.
Yes, of course, we have some viewers about it.
Yeah, you can reduce the precision of the inputs and weights, and for example in a CNN, or also you can in implementations, of course, on FPGA and things, you can go with multipliers which are not exact. to be more precise, approximate multipliers, approximate adders in general. Any operand and operator in a complex computation like a neural network can go inexact. And we need approximate computing techniques, which is diverse wide techniques. For example, we don't have just one way to make an adder or multiplier in exact or approximated. So what my focus was on during this research was that we need to find which approximate computing technique is best for each application. For example, you have this spiking neural network. Let's say it's doing some image processing task. Yes, of course, it's approximate in nature, and it can tolerate some accuracy loss, but there is a limit to the accuracy loss. So if I have 5 different approximate computing techniques, we can't apply all of them.
At the same time?
Yes,
okay.
You can apply all of them at the same time, but the thing is, you have to measure somehow, you have to evaluate how much accuracy of the computation is reduced, and at the end, as a result, how much the accuracy of the network classification task in an image processing task is reduced. Because you can't just go and degrade the accuracy as much as you want.
Yeah, but I'm sorry, but how much resource does these techniques consumption in the real world project or situations?
For example, in a convolutional neural network, you have thousands, millions of multiplying additions, and you are just saving millions of weights.
Okay.
And we are not in a situation that we can consume as much as energy as we want. By, I don't know, 2040, the whole energy that you need is going to be much above the energy that all the world's resources can produce. So at some point we have to stop and look what we can do. There are IoT devices, there are I don't know, sensors, there are so many
cameras,
applications.
TVs, everything, like,
yeah,
because everything is now smart, I guess.
Yeah,
as we're going, everything is,
of course.
AI is going to involve in every kind of appliance and technology.
But not even AI, even I don't know. You want to monitor the temperature of this room, and you're writing a code for it. And for example, if your sensors are reporting something like 20 degrees, 20.0001 is not important to anyone.
Exactly.
It's the temperature of the room. So you can go with
a normal thing, a normal tool, and just put it on. And
yeah, for example, you just imagine that you are averaging over the data received by 4 sensors. Of course, they are not very much exact, and you are averaging over that, and you are monitoring the room's temperature, and you are controlling it. So when you average over those 4 numbers, you just don't need to do it very exact. You are not making a refrigerator for some special kind of medicine. It's the room temperature. It can be 20 reported as 21 is not that important as long as
1 degree isn't,
yeah,
doesn't matter.
Yeah, even in data scale, it's not that important. So you can go with inexact numbers and do the calculation in an approximate way and save energy. So,
all right, thank you so much for joining us today. I really appreciate it.
Thank you for having me here.
No problem. No. It's my pleasure.